Winds and storms. Learning objectives. Rain. Thunder and lightning. Winds. Natural disasters. A number of phenomena keep taking place in nature. We term these happenings as natural phenomena. While many of these occurrences are useful or favorable to human beings, some of them are harmful as well. For example, occurrence of rainfall in normal course is essential for cultivation of crops in many parts of the world, but the excess of rainfall, flood, can result even in wiping out the entire living populations in the affected region. Rain, thunder, lightning, winds, storms, floods, etc., are some common natural phenomena that periodically take place in nature. Here, in this chapter, we shall learn about how these phenomena transpire in nature. Rain. As you might have read earlier, rain occurs as a result of evaporation and condensation that keep taking place in nature all the time. Let us understand this mechanism in the following ways. A. Evaporation. Water is transferred from the surface to the atmosphere through evaporation, the process by which water changes from a liquid to a gas. Most evaporated water exists as a gas outside of clouds, and evaporation is more intense in the presence of warmer temperatures. This is shown in the figure, where the strongest evaporation is occurring over the oceans and near the equator. You can understand the process of evaporation through a simple activity. Take some water in a pan and keep it on a burning gas stove. Do not forget to take permission of an elder before doing this activity. See what change takes place in water after some time. You see that on heating, water soon starts boiling and it changes into water vapor, steam, during this process. So, this is what we call evaporation. Evaporation process. Condensation. Precipitation. Evaporation. Infiltration. Snow melt and runoff. Evapotranspiration. Plant uptake. B. Condensation. Condensation is the change of water from its gaseous form, water vapor, into liquid water. Condensation generally occurs in the atmosphere when warm air rises, cools and loses its capacity to hold water vapor. As a result, excess water vapor condenses to form cloud droplets. The upward motions that generate clouds can be produced by convection in unstable air, convergence associated with cyclones, lifting of air by fronts and lifting over elevated topography such as mountains. Thus, you see that the water that goes up as water vapor, through evaporation, comes down as rain through condensation. Now you know the complete mechanism of how rain occurs in nature. Condensation is followed by rain. Clouds. Rain. Thunder and lightning. The flash of a lightning strike and resulting thunder occur at roughly the same time. But light travels at 186,000 miles in a second, almost a million times the speed of sound. Sound travels at a slower speed of 1/5 of a mile in the same time. So the flash of lightning is seen before thunder is heard. By counting the seconds between the flash and the thunder and dividing by 5, you can estimate your distance from the strike, in miles. But why does lightning cause thunder at the same time it strikes? Thunderclouds. What is lightning? To put it simply, lightning is electricity. It forms in the strong up and down air currents inside tall dark cumulonimbus clouds as water droplets, hail, and ice crystals collide with one another. Lightning. Sci facts. Every year, winds loaded with evaporated water, vapor, flow from South India via Northeast India to North India. This water condenses into clouds on reaching North India and falls down as rains. These winds are known as monsoon winds, and the rains occurring due to them are called monsoon rains. Lightning causes thunder because a strike of lightning is incredibly hot. A typical bolt of lightning can immediately heat the air to between 15,000 to 60,000 degrees Fahrenheit. It's hotter than the surface of the sun. A lightning strike can heat the air in a fraction of a second. When air is heated that quickly, it expands violently and then contracts, like an explosion that happens in the blink of an eye. It's that explosion of air that creates sound waves, which we hear and call thunder. When lightning strikes very close by, we hear the thunder as a loud and short bang. We hear thunder from far away as a long, low rumble. Lightning always produces thunder. When you see lightning but don't hear any thunder, the lightning is too far away from you for the sound waves to reach you. Light and sound will always move at different speeds. And lightning will always produce thunder because of a strike's high temperature. So no matter what, you will always see a flash of lightning before you hear thunder. Twins. You have read that air is a substance which has its own weight and occupies a definite space. You also know that air blows. When it blows fast, it is called wind. Have you ever thought as to what makes the air or wind blow? Perhaps not. To know, you must, first, understand the air pressure. Wind's effect. Direction of winds. Air pressure. As a natural tendency, air puts pressure on its surroundings. It puts pressure in all directions, viz., upwards, downwards as well as sideways. Since air is present everywhere, it does not find much variation in pressure it puts on its surroundings. For example, the air pressure within your living room is about the same as that in your kitchen. This is why the air does not blow on its own. On the contrary, if the air pressure at a place falls, the air from the surrounding areas rushes to this place until the uniform air pressure is established once again. Thus, it is the variation in air pressure which causes the blowing of air. Now you know that the air pressure variation is a must for the air to blow. There are a number of factors that bring about variations in air pressure. For example, temperature, humidity, etc. When, owing to any of these factors, air pressure at a place lowers, the air from other places rushes in towards that place. The greater the variation in air pressure, the higher is the speed of air flow. So, while slight changes in air pressure bring about the mild air flows, which may be pleasant to us all, drastic changes in air pressure can bring storms or cyclones as well, which may cause great damages to life and property. Anemometer. We know that wind speed and wind direction play an important role in the formation of storms or cyclones. It is, therefore, necessary to measure wind speed and wind direction at a place. The wind speed is measured by an instrument called anemometer. A common anemometer consists of 3 or 4 cups mounted on a rod which can rotate freely. The cups catch the wind and rotate according to the speed of wind. The speed of wind, in km per hour, is read from the scale situated at the base of the anemometer. The anemometer is installed on a tall mast where the wind blows freely around it. Anemometer. Wind vane. A weather vane is also called a wind vane. It is a tool for measuring wind direction. It spins on a rod and points in the direction from which the wind comes. The weather vane is one of the oldest weather tools. The part of the vane that turns into the wind is usually shaped like an arrow. The other end is wide so it will catch the smallest breeze. The breeze turns the arrow until it catches both sides of the wide end equally. The arrow always points into the wind. The arrow tells you the direction from which the wind is coming. Wind vane. Activity 18.1. Making a wind vane. Materials required: paper and pencil, scissors, cardboard, compass, plastic soft drink bottle, plastic drinking straw, a rectangular piece of wood and a knitting needle. Procedure. What is a weather vane? When have you seen weather vanes? Let us try to make a wind vane. With the scissors, carefully cut an arrow with a tab from the tag board, as shown. Remember that scissors are sharp, so handle them carefully. Bend the tap slightly so the arrow turns easily when you put it in one end of the straw. Put the other end of the straw in the bottle. Remove enough rocks from the pan to make room for the bottle. Pile the rocks back around the bottle so it won't be blown over. See illustrations below. Now fix the knitting needle from below into the hole of rectangular wooden base. Put the bottle on the wooden box. A compass always point north. Use your compass to find north, and then mark the four sides of the bottle E, W, N, and S with a felt pen. Set your weather vane in a high place such as the top of a playhouse or a slide. Make sure it does not wobble or tilt, and that it catches the slightest breeze. Watch your weather vane closely and then describe how it works. Test it on windy days and again when there's just a light breeze. You have made a weather vane. If the wind is blowing from the south, the wind is usually warm. If the wind is blowing from the north, the wind is usually cooler. Natural disasters. The natural phenomena, as described above, brings about some other changes in nature which are very harmful to mankind. Such natural phenomena are called natural calamities or natural disasters. Some major natural disasters are discussed below. 1. Floods. A flood is when there is too much rain to be absorbed by the earth and the water stays on top of the earth and runs off to the rivers and seas. The water fills up the rivers and then the rivers overflow their banks and the water comes onto the land and a flood devastates the land. In spring, when there is a big melt of the snow in the mountains, the water makes its way to lower areas and the rivers and seas. Sometimes there is a blockage in the runoff and again the water overflows and goes on the land and makes a flood. To tackle the frequent or regular occurrence of floods in a region, the following attempts must be taken by the administrative authorities. Flood. Construction of dams and embankments. Construction of new canals, distributaries, etc. to direct water flow into rivers. 2. Storms. Storms occur when winds blow very fast. When a low-pressure zone is created at a place as an effect of different climatic factors, air from far and wide rushes to fill the void thus created. The winds blow so fast that the trees on its way are uprooted, houses are blown away, electric poles, telephone poles feel the impact and fall to the force of fast winds. Storms. The occurrence of storms, though largely unpredictable, can now be predicted before its occurrence by meteorological department. 3. Cyclones. Cyclones are, perhaps, the most destructive among all natural disasters. A cyclone is a storm accompanied by high-speed whistling and howling winds. It brings torrential rains. Fast winds, together with water currents, ravage the habitations where the chances of survival for any living beings is very rare. Like storms, cyclones are difficult to be predicted in advance. However, meteorological department is able to warn people beforehand. Cyclone is known by different names by different countries. Such as in USA they are called hurricane and in the Indian Ocean these are known as cyclones. In China Sea they are called typhoons. Cyclone. Formation of cyclones. Hurricanes form in the tropics where the water and air are warm and moist. There are many factors which need to be just right in order for a hurricane to form. Scientists aren't sure why all these factors are needed but know that they are important. One ingredient is a low-pressure area which forms over a large area of warm water. The air being drawn into the central low pressure is curved due to the Coriolis effect. Surface friction also causes the wind around the low to spiral toward the center. This gives the hurricane a circular rotation. The incoming air must go somewhere, so it rises. This rising air, which is saturated with water, cools and condenses to form clouds. The latent heat given off when the water condenses causes the upper air to warm and increase in pressure. This high pressure area is the reason why weather is nice in the eye of a hurricane. This is the start of a feedback mechanism which continues to intensify the hurricane as long as there is warm water from which to draw energy. Once a hurricane moves over land, the large energy supply from the ocean is no longer available and the feedback no longer intensifies the storm. As it continues over land, it begins to lose strength and eventually dissipates. Formation of cyclone. Damage caused by a cyclone. Trees fall down on roads. Electric power lines, telephone lines and street light poles may fall down and cause disruption, especially for road traffic. Trees can fall over cars. Cars and humans can possibly be stranded between fallen trees. Damage to mobile phone base stations may worsen the network. Boats may come loose from mooring. Some partly detached in roofs. Trees fall over buildings. Banners and tarpaulins on building facades and roofs may be detached. Building materials blow away from construction sites. Cyclone forecasting and warning. The Indian Meteorological Centre provides a multitude of services. Its primary activity is forecasting. It performs cyclone warning services for Orissa, West Bengal, Bay of Bengal and Arabian Sea. Cyclone warnings are disseminated through a variety of communication media, such as radio, television, print media, telephones, fax, telex, telegrams, police wireless network. A specially designed cyclone warning dissemination system which works via the INSAT satellite provides area-specific service even when there is a failure of conventional communication channels. Warnings are issued for general public, fishermen, farmers and different categories of users such as central and state government officials responsible for disaster mitigation and relief, industrial and other establishments located in the coastal areas, railways, aviation, communications and power authorities. The cyclone warnings are issued in 4 stages. The first stage warning, known as cyclone alert, is issued 48 hours in advance of the expected commencement of adverse weather over the coastal areas. The second stage warning, known as cyclone warning, is issued 24 hours in advance. Effect of cyclones. Tornado. A tornado is a violent storm with a column of rapidly rotating winds, having the appearance of a dark, funnel-shaped cloud that reaches from the sky to the ground. Most of the tornadoes form from thunderstorms. Before a tornado starts, large thunderclouds appear in the sky. One area of the thundercloud becomes specially dark and dense. The air in this area is rotating quickly. A funnel-shaped cloud begins to form and extend downwards to the ground. The diameter of the narrow end of a tornado, which touches the ground, can be as small as a meter and as large as a kilometer, or even more. Due to very low pressure in it, the funnel of a tornado sucks dust, debris and everything else, including people and vehicles, near its base and throws them out near the top. A tornado moves across the surface of land, or sea, producing very high-speed winds. A violent tornado can travel at speeds of about 300 kilometers per hour. Most of the tornadoes are weak. Tornadoes are not very frequent in our country. A tornado. Keywords. Air pressure. Pressure exerted by air on its surroundings. Cyclone. Huge whirling winds from seas. Lightning. Bright spark originating in sky resulting from collision of charges. Natural phenomena. Changes or events that occur in nature. Natural disasters. Calamities or disasters taking place in nature. Summary. Many natural phenomena keep taking place in nature. Rain occurs through 2 sub-processes, viz., evaporation and condensation. Thunder and lightning are produced from the collision of similar charges in sky. Wind begins to blow due to fluctuation in air pressure. Natural phenomena, which are harmful to mankind, are called natural disasters. Earthquakes originate due to movement of tectonic plates and their collision